Alright, let's have a quick look at graphing reciprocal trig functions. So obviously it's going to involve graphing of trig functions, and then reciprocal, you remember, is 1 over. So there's a couple things that happen with that. So if we look at this, we can do this by table, but we're not going to because that's too slow. But if we look at the graph of y equals sine x, you'll notice a couple things. So from the table you can see as we go from 0 towards 1, the numbers increase, which is consistent with what we've done when we graph sine. What we really want to pick off from here is this entry right here. This is the key piece. So the graph of sine of 90 is 1, but the graph of cosecant, which is 1 over sine theta, or sine x, you'll notice has the same shared value. But on each side of that, instead of the values going back down to 0 like they did over here, okay, the values on each side of this one actually go up. Okay, and we'll see that reflected in our graph in a moment here. So you can always make a table, not always the most helpful thing though. But let's take a look at this. We'll draw our graphs here. So graph of sine, we draw our 5 key dots. Okay, at the quadrants, this is 0, 90, 180. We try and draw a nice smooth curve as best we can. That's not too bad with a mouse. Maybe we'll move that guy up just a little bit. There we are. So now the reciprocal of this, we have to remember there are some key problems. So reciprocals as being 1 over. 1 over a 0 is a problem for us. So this guy right here is a problem, this is a problem, and this is a problem. So what happens at those is that we end up with asymptotes. So I'm just going to put in an asymptote line there. The asymptotes are for the reciprocal, not for the original. Okay, and then we have one more here. And now if we go back up to our data for 1 minute, our generated table, we can see we have this value at 1, so there's a shared point right here. Maybe I'll change to blue. There's a shared point right here. And then if I go to either side, we can see those values are actually increasing. And what we find is that this goes up. This goes up. And then if you were to do the same table approach and investigate a little more deeply, you would see that 1 over negative 1 is still negative 1. And then all of these points would go down like that. So the blue graph is y equals cosecant x. And that's another one we can add to our parent graphs. And you'll notice if we draw sine first, it's really not that bad to have to go back in and figure out what the reciprocal is. So the red graph is sine. The blue graph is cosecant, which is the inverse of sine, the reciprocal of sine, I should say. You'll notice it has asymptotes wherever the original sine had x-intercepts. Okay, and what we'll find in the future, there's some other trade-offs, but let's go to cosine next. So secant is 1 over cosine. So again, we're going to start with our cosine graph just to get it started. We'll draw our 5 key points. We'll make a nice smooth curve as best we can, especially when you're working with a mouse. So there's cosine. That's y equals cos x. And I'm going to use green for asymptotes again, so wherever there are x-intercepts of the original graph, we know we're going to have asymptotes on our reciprocal. And now they do have a shared point again. This value has a y value of negative 1. So if you take 1 over negative 1, you get the exact same thing. Okay, and so what we find, just like sine, these guys are going to go down like this. Over here, this one would be shared as well because it's a value of 1, and 1 over 1 is just 1. And same here. Now that's just one cycle. Obviously there would be another portion on here, but that's just outside of the cycle. So the solid blue line is this guy right here, y equals 1 over cos x. And again, you can make a table if you like to help. Just keep in mind 1 divided by 0 is undefined. So you can test on either side of the 90, like 91 and 89, and see what happens. Okay, now the last one's the tricky one. So tan x, I'm just going to graph tan x in red over here. So tan x has the weird shape, these are 90s, of going up on the asymptotes. So tan x had asymptotes to start with. Okay, so tan x looks like this. And that's our graph of tan x. So now if we want to graph cotangent x is just 1 over tan. So our blue graph will be 1 over tan x. Okay, so as we look at things, now this is where things get a little bit different. The x-intercepts for tan x aren't going to be, pardon me, let's start that again. The x-intercepts of tan x will still be asymptotes for the new graph. The asymptotes of tan x will become x-intercepts for our new graph. And just take a minute, I'll have to digest that. Hopefully I said it right. I'm a little bit hazy here with this cold. So what we find is as this one gets closer to 0, as the red graph gets closer to 0, 1 divided by smaller numbers makes larger numbers. And they're all positive. So this guy is going to go up right here. Over here on this value, we're going to see as the red graph approaches 0 from the negative side, this graph is going to go down. Okay, and then what we'll see as we approach the asymptote of the original tan x, what we're going to find is that we can actually pass through that point. And there's our graph, or a starting point of our graph for our cotangent x, or our 1 over tan x. Alright, so now if we come back over here, you'll see there's a repeat pattern as we approach the 0 from the positive side here. So I'm approaching here. Then I'm going to have another graph that comes down to 0. And then this guy's going to come back down like that. So the blue graph is 1 over tan x. The reason we can pass through this point right here, just to highlight this, tan x by definition is y over x. When this x value here goes to 0, we essentially have a straight line, a vertical straight line, and our x value is 0. And that's why the original tan x can't go to 0. But cotangent x, one of our definitions is, I'll make it cotangent theta. Cotangent theta, by definition, is x over y. And so in this example, you can see the y value, or the x value, can actually go through 0, and that's why we have an x-intercept on the cotangent graph where the original tangent graph had an asymptote. Okay, so those are our basic parent curves again. Again, tan x or cotangent x, not that popular, difficult to model. These two here we'll definitely see a little bit of. And so we're just going to apply some transformations to it. And I'm going to just do this because I see this every year. People will draw things in a different order that suits them. I just want to show you that the order does matter. And we'll try and do method 1 more often than not. So let's take a look. So we're going to mark off our 90s, our 180s, our 270s, our 360s. And I'm going to look, the maximum y value I need is 3, so I'll make that 1, 2, 3, and I'm going to move it to the right 90 degrees. Okay, so let's look at cosecant. So the first thing we're going to do is draw our base curve. So we'll draw our base curve for sine, put our 5 key dots. There's my base curve for sine. Then I'm going to find the reciprocal, the 1 over. Okay, so then the 1 over is going to be wherever there are asymptotes, wherever there are x-intercepts, there are asymptotes. So I'm just going to draw those in there right now to help remind me of where the confinement of the graph is. And then I'm going to graph, I'll use green. So this guy is going to come down like this. It has this shared point, and then it's going to go up. On this side, there's a shared point, and then these are going to go down. Okay, so now we've taken care of the base curve and then the reciprocal, and now we'll do our transformations. So now this is a vertical stretch out front, so I need to multiply the y values by 3. So if I take this y value here and I multiply it by 3, it goes from 1 to 3. And so my graph stays just like that. This one goes from -1 to -3. And we don't really have to keep track of all the big numbers, just the key points. And then lastly, we'll do our right 90 degrees. So we're going to pick that whole graph up. Maybe I'll just drag it and see if it goes in one piece. We're going to move right 90 degrees. So we'll move this guy over right 90 degrees. We'll move this guy over right 90 degrees. And that would be my transformed cosecant done in this order right here. Okay, now if we do the exact same thing, but we're going to just change the order up a tiny little bit. And we'll see if it actually has an effect. Kind of already given away that it does, so let's just take a quick look at what happens. Just making it, I have all my parts. Alright, so let's go through. I gotta move my screen up here. And let's bring this guy down so I can see it. There we are. Okay, so same thing, we draw our base curve. Going a little quick here, sorry. Keep track of my key points. Okay, and now, so I've done my base curve. Now I'm going to do my transformations and then take the reciprocal, and you'll notice there's a difference. So let's do the transform. We're going to multiply by 3, so it's going to get taller. And then I'm going to move the whole thing right 90 degrees. Maybe I'll just draw it. Whoops, I didn't need that. Let's just draw it. Okay, so we'll make all those dots move over 90 degrees. So this is my new dot here. My new dot, it moves over here. And I have to keep track of where this goes down. Like that. That's pretty good. Okay, so that's the transformed sign, and now if I want to find the reciprocal, okay, I can put my asymptotes on here just to help me see where I have to cut it up. Okay, and then if I find my reciprocal now, my reciprocal I'll do in heavy black. It's going to have the same shared point, okay, and it's going to be bound and it's trapped by those asymptotes. So same point down here, and then if you draw them, okay. Okay, so now when you take a look, you're going to say, hey, those things are exactly the same. You said they're going to be different. Okay, and they are going to be different. And the mistake I made here, okay, to help illustrate this, is this movement right here. This guy right here has a y value of 3. Okay, the reason we can write in this green graph up here as touching the same point is because 1 over 1 is just 1. The problem with this is this has a y value of 3. Well, 1 over 3 isn't 3. So what we find is that this graph is not going to just touch here. This graph actually starts at 1 over 3, or 1/3. So this one would, instead of being at -3, would be at -1/3. And that's where you start to see the differences. Okay, so if you want to keep your life a little bit easier, concentrate on method 1. Draw the base curve for your sine. then find the reciprocal, and then do your transformations. Easiest way to do it. Okay, that's going to take a little practice. It's a little tricky, but it's not that terrible. Okay, page 353, number 7, if you can try a couple, and we'll talk about it more in class.